Thank you for joining us on this question, exercise 2D. I'm going to be looking at question 4. And it says, let us suppose that for an orchard involving a particular type of fruit tree, the average weight of fruit, W, produced per tree in a year depends on N, the number of trees per 100 square meters. According to this rule, W equals 600 minus 15N. Now, N is between 10 and 25 number of trees per square 100 meters. And if we get dWdN, we get a value of negative 15, and that means it's dropping by negative 15 kilograms per the number of trees per 100 square meters. 100 square meters. Well, because we can't substitute, we can't solve that equals to 0. Normally you'd say, okay, to solve this, what is the optimum value? We would solve the derivative equals 0, and therefore get 0 equals negative 15. That doesn't work. So what we're doing is the derivative is dropping by 15 kilograms every time we increase N. So what we've got is, if we look at our two extreme values, 10 and 25, if you substitute what is the weight when N is 10 trees, we would get, therefore, the weight would be 600 minus 15 times 10. So you've got 450, and so we would get kilograms as our weight if N was 10. Now, our weight when our other extreme value, which is 25, we get our weight. Determine the value of N that gives the maximum total weight of this fruit. Therefore, the value of N that gives us the maximum weight is actually, in this range, is N equals 10 trees per 100 square meters. And does it say it doesn't ask for the weight. We know the weight's going to be 450 kilograms, but it doesn't ask for that. It just wants the value of N is 10 trees per 100 square meters. 100, actually, can I just make sure that doesn't say 100 squared? I want to say 100 square meters. This is an interesting question. It was a linear line, W equals 600 minus 15N. You could probably realize that's a line which starts at 600 on the y-axis, and the gradient is negative 15. But you only count it between the values of N as 10 to 25. And so it would be like a graph which starts at, say, 10, 450, and goes down to 25, 225, and that's that coordinate, and it would be like a straight line that's dropping 15 every tree. And in that range, 10 is the number of trees that gives us the maximum weight of 450 kilograms. So that's, in fact, the point that we're looking for. I hope this has helped. Until next time, stay happy.